Hello, my name is Max, and the problem I'm solving today is problem number 5. So the first thing we want to do is to define the different parts of this curve. So first of all, since we know that the absolute value of this represents these curves, we know that this curve will be minus 3/2 x plus 3, due to the intersect here, and this curve will be 3/2 x minus 3, due to the intersect with 3 over here. Now, to determine the minimum point of this absolute value curve, we know that we find that when the absolute value is equal to 0. So this is quite simple. It's just 3/2 x minus 3 is equal to 0 to find min x value. To do this, it's basically just going to be 2. As you can see, it's going to cancel out, so x is equal to 2. Now that we know that the vertex of x is essentially at 2 in this curve, we can now try and solve the quadratic equation, because we know that the vertex, I'll just put the quadratic equation here, that's the quadratic equation of this curve right here. So the quadratic equation of this curve right here, I'll just write that this point is 2, 0, is, okay, so I'm just going to write the general form, y is equal to ax squared plus bx plus c. I'm going to rewrite this so it's easier, which is y is equal to x plus b plus c. In this form, now we plug in the values, so it's going to be 3 is equal to this is going to be negative 2 squared plus, actually it's minus 3. Then it's going to be 6 is equal to 4a, therefore a is equal to 6 over 4, which is equal to 3 over 2. This means that the entire quadratic equation is equal to y is equal to 3/2 x minus 2 squared minus 3. The x minus 2. And now, so this is going to be easier for the integration to get into the form that is necessary. It's going to be easier if I multiply this out. So it's going to be y is equal to 3/2 x squared minus 3/2 4x plus 3/2 4. That is the same as y is equal to 3/2 x squared minus 6x plus 6 minus 3, which is plus 3. So now that we have the quadratic equation and the equation of this line, I'm going to use half of this area and then multiply it by 2. I'm going to find the integral of the top function, which is this, minus the integral of the bottom function again. So to do this, I will do it from the values from 0 to 2, as we found that this is 2. So it's going to be from 0 to 2, and it's going to be the integral of minus 3/2 x plus 3 minus 3/2 x squared minus 6x plus 3 dx. So this is the same as 0 to this is the same as minus 3/2 x plus 3 minus 3/2 x squared plus 6x minus 3 dx. Now, to further simplify this, this is the same as the integral from 0 to 2 of minus 3/2 x minus 3 over 2x squared plus 6x dx. Now, to even further simplify this, it's going to be in the form of 0 to 2 once again, of minus 3/2 x squared plus 9/2 x dx. Now, since this will only give us the area of this 1/2, I now have to multiply it by 2, so I'm going to put a 2 here, and that is the integral of 0 to minus 3. See, the 2 multiplies out here, so it's just minus 3 x squared plus 9x dx. So this is actually the form that they require. 0, t is equal to 2, a is equal to -3, b is equal to 9, and c is equal to 0. Thank you. So even though this is not part of the grade, just for the sake of practice, let's finish trying to find the area of this problem. So I'm already going to start writing it in this form. So this is minus 3 times by 1/3 x squared, x to the power of 3, plus 9 times 1/2 x squared from 0 to 2. So this will simplify to negative x to the power of 3 plus 9/2 x squared from 0 to 2. Now if we actually plug in the values, we know that since this is the 2 minus the 0, we know that the 0 will be minus 0 if we plug this into here. So x to the power of 2 to the power of 3 is 8, so it's -8. So it's -8 plus 2 squared is obviously 4. 4 times 4.5 is 18. So it's -8 plus 18 minus 0 is equal to the area. The area is equal to 10 units squared. Okay, thank you, that's it.